Yeah. So in our earlier lessons, we learned how to calculate the portfolio expected return, the portfolio standard deviation, the covariance, in that order. Now, I gave you certain clues that if, let's say, you are going to calculate for the covariance and you have been given the correlation coefficient, then you must calculate for the covariance, where we use the two standard deviations. So the standard deviations of the investment multiplied by the correlation of the investment gives you the covariance. If you have a question where you have been given the covariance straight away, you don't need to calculate for it. You just use it straight. In calculating standard deviation, you can calculate your standard deviation straight away, or you can calculate the variance, and then you square your variance, and then you get your standard deviation. So with this particular illustration that you are seeing over here, we have two investments, the stock fund and then the bond fund. You have the various economic sections of these investments: recession, normal, and then booming section of the investment. For the stock fund, the section returns are for recession is 7%, normal is 12%, boom is 28%. The rate of return for bond fund is 17, 7, and then how much? 3% in that order. Now, we are going to learn how do we determine the portfolio expected return here, assuming we have not been given the individual expected return. The individual expected returns here are the 11 and then the 7%. And I am sure you know how to get this 11 and 7% if I ask you right now to determine it. If you don't know how to do that, you go back to unit 1, where we learned about the stand-alone investment, where we say, okay, we have not been given the probability. So we divide odd 1 by 3, we get 1/3 multiplied by this, 1/3 multiplied by that, 1/3 multiplied by this. You add all, you get 11%. This one to the same thing, 1/3 multiplied by 17, 1/3 multiplied by 7, 1/3 multiplied by -3, you get 7%. So if you don't know how to determine the individual, how they got this 11 and this 7 here, you go back to our earlier illustrations, or you go to the YouTube page that I've launched for you, Benport Consult YouTube page, and then you get how to understand the individual investment return from there. But let's go on. So we are going to calculate the portfolio expected return, assuming we were not given this 11 and this 7% over here. So assuming you have not been given it, how do you then calculate the portfolio expected return? Now, in an attempt to do that, you first of all calculate what we call the portfolio possibilities. The portfolio possibilities. Now, in our earlier illustrations or in our earlier discussion, we came across how to calculate individual expected return, and we said it is equal to what? The possible return, which are called the possibilities, multiplied by what? The probabilities. So therefore, we need the possible return or the possibilities. In an attempt to do that, this is portfolio building. I told you that before you build a portfolio, there is one thing you have to take note of. And what you have to take note of is the weights. Without the weights, you cannot build a portfolio. So if you have been given 2 investments and we are building a portfolio, we assume that the weights is 50-50 if you have not been given the weight. So if there are two investments, you assume a weight of 50-50. If you have been given the weight, you use the weight. We came across a situation where you can be given the weight of one. Don't expect the weight of the other. So if there are two investments, and then they said the weight of one is 60%, then the weight for the other should be how much? It should be 40%. You have three investments. The weight of one is 20%. The other is 30%. And they didn't give you the last one. So don't expect the last one to be given to you. You should be able to know that the last one is 50%. Because if the two, one is 20, the other is 30, then the last one automatically is 50%. So these are the scenarios that we created that day in identifying the weight if you have been given parts or you have not been given at all. In this situation, there are two investments. So we are assuming that the weight of the investment is what? 50-50. The weight of the investment is 50-50. So bear in mind, in portfolio building, the weight of the investment is very, very important. If you don't know the weight, or if you don't get your correct weight, you cannot build a portfolio. So how then do we determine the individual investment possibilities? We said the weight of one, which is the 50%, the 50% here, multiplied by the first return, this 7% here, negative 7% here, plus the second 50% multiplied by the 17% over here. So when you do that two multiplication, the answer you should be getting is 5%. So we have gotten the first possible return for the first section. You come to normal, the second section. The weight of the investment, 0.5, that's the 50%, multiplied by the 12%, this particular 12%, then the second 50% multiplied by this 7% over here. When you get these ones, you total, you are going to get a final answer of 9.5% or 0.95%. Then you go to the last section, which is boom. So you pick the first weight, which is the 0.5 for the first one, multiply by the second, the 28% here, plus the second 0.5 multiplied by the negative 3% over here. So at the end of the day, you have determined your individual investment possible return for the section. Or we can also call them the individual section portfolio what? Return. The individual section portfolio return. And bear in mind, I said we are going to determine the portfolio expected return, assuming we were not given the individual investment return. Are you getting the scenario? So it means that we can determine the portfolio expected return in two ways. The first method is where you have been given the individual expected return. The second method is where you have not been given the individual expected return, which I'm doing now. I already did the first method with you already. Are you getting me? So don't go and see the question and be confused. You must understand the variables you have been given. And once you know the variables you have been given, you will know how you are going to use these variables to arrive at a final answer. Now let's carry on. Now we know our individual possible return or the sectional portfolio returns to be 0.5, that is 5%, 0.75, 0.095, that is 9.5%, and then 0.125, that is 12.5%. Now, the question is, what is the portfolio expected return? Now, we said that we were not also given the probability, and that one that I told you you should be able to know. If you have not been given the probability of the investment at all, we assume equal probabilities for all. We assume equal probabilities for all. And I already tell you that probability should be always equal to what? 1. The probabilities is always equal to 1. So if all the investment we have is equal to 1, and how many we want to get equal investment for them, then how many investment sections do we have? We have 3. 1, 2, 3. So we have section 1, section 2, and section 3. Recession, normal, and boom. So if you want to know the probabilities for the investment, then we divide this one by the 3 sections that we have, and you should get the answer to be what? 1/3, or 0.333333. Now, you using 1/3 will give you an accurate answer than using the 0.3333, because at the end of the day, you'll be approximating. So to get our portfolio expected return, it is equal to the 1/3, the first weight, multiplied by the first sectional expected return, 0.05. This particular 5% that we had over here is what we are replicating over here now. Plus the next probability, 1/3, multiplied by the second sectional expected return that we have, the 0.095 over here, plus the third 1/3, multiplied by the 12.5 that we have here, the 0.125 that we had over here. So this particular one is what we had over here. And so therefore, when you sum up everything, you should be getting 0.09, or 9%. So your answer you should be getting is 9%. Now, somebody can also do it this way. He or she will say 1/3 multiplied by 0.5 plus 0.095 plus 0.0125, then you get 0.09. But take notes. Before you use this particular method, the one I have highlighted, you will only use this particular way of solving a question if the investments have equal weights. If the investments have equal weights or equal probabilities, then you can go this way to determine your answer. The reason why I said you can use this one is that all of them have probabilities of 1/3, 1/3, 1/3. So because of that, you can comfortably put the 1/3 here and then put all the various sectional returns in one bracket. And why are they all adding in the bracket? Because each and every one is adding from the next section. I get in the scenario. So that is why we are adding inside the bracket. But my humble advice to you is that to always be on the safer side, go with this method, the one I just highlighted. to always be on the safer side, go with this method. And once you go with this method, the likelihood of you making a mistake is very low, or the chances of you making a mistake is very low. But me, I will show you all the methods, and then you go by the one you think you are okay with. If you understand very well, you can go by this method. But as beginners, I will always recommend this particular method for you, so that when you gain ground in the subject or in the topic or in the area where you are learning in, you now go using different methods. Any question? Who is having a different answer? Please be calculating, because my answer I may be getting here might be wrong. And so therefore, if you are copying it hook, line, and sinker, and I'm wrong, you also go with a wrong answer. So anytime we are working, kindly use your calculators and double check the answers and see if what I have put on the screen and the answers here are matching, because I may make a mistake. So this is the situation or the circumstances where you calculate the portfolio expected return when you have not been given the individual investments return. Now, if you have any question, raise up your hand, I call you, and then we go on. Now, the second scenario, in the situation where you have been given the individual expected return. So in your handout, go look on the page, look on your handout, you see this particular one over there, the expected return of 11 and 7%. This is what I'm saying. So the first illustration that we have done, yes, Nick, hand is up. Nick, let's hear you.
Hello.
Nick.
Taima?
Yes.
Taima, hear me?
Yeah, you're on floor. Let's hear you.
Please, I have a network challenge. So after the individual this thing you were calculating, I didn't get anything. So if you can please go back to me.
Okay, you mean from here?
Yes, please.
Okay, so you got this one, right?
Yeah.
Okay, so we are saying that once you have not been given the individual expected return, you must find the sectional portfolio return or the individual portfolio return for the various sections. Are you getting the scenario? So we found, let's say for recession, this is the portfolio return for recession, 5%. The portfolio expected return for normal is 9.5. The portfolio expected return for boom is 12.5. So you find the sectional portfolio return. Then you now come and weigh this portfolio expected return using the portfolio weights or using the weights of the investment. Now, we're not giving the probabilities of the various sections. So we are assuming that each of the sections here have equal probability. And because we have 3 sections, and we are saying that probability is always equal to 1, then what do? You divide the 1 by 3. And your answer you should be getting is 1/3 or 0.33. And once you have your 0.3333, you either use this as 0.33 or the 1/3. But my advice was that when you use the 0.333, your answer you are going to be getting is going to be plus or minus the accurate answer. But when you use the 1/3, you are going to get the exact answer. So when we use the 0.33, we might be getting 8.9 or 9.1. over here. Are you getting the scenario? So we use the 1.3 so that you get the exact answer. So you said the 1/3 multiplied by the first section portfolio return, which was a 5%, plus another 1/3 multiplied by the second sectional portfolio return, which you have to be 9.5, plus 1/3 multiplied by the third sectional portfolio return, which was 12.5. So when you do all and you add all, you are going to get 9% or 0.09. This is first way of getting it. The second method is that this is for the students who think they are very good or those who think they understand statistics very well. They will say that, okay, since all of them are having equal probabilities, then why don't bring one of the probabilities outside the bracket? That is 1/3. Then because all of these factors are adding each of them, then I'll bring this one at the 0.5 here, the 0.95 here, the 0.125 here. Add all these one, all these three, get an answer, multiply it by 1/3, and I will also get the 0.09. But I always recommend the students to use this one, the one I have highlighted, because your chances of making a mistake using this particular method or the highlighted one is very, very minimal. But when you use this one, your chances of making a mistake is very high if you don't understand the weights very well, you don't understand the probabilities very well, and you are fond of doing this, the day you'll be given different probabilities, then you'll be found wanting. But with this method, whether the probabilities are the same or they are different, everything goes. You get the same answer. Nick, are you with us now?
Yes, please.
Okay, that's good. So we went ahead and then we are saying that, okay, let's also determine the portfolio expected return, the 9%. Let's see how we also find it. If you have been given the expected return, the individual expected return, are you getting the scenario? Now, to find that one, we know the weight of the investment was 50-50, and you have been given the expected return to be 11 and 7. So this is what I just extracted from here, and then I place it over here for you. So how then do we find the portfolio expected return? We say the 50% multiplied by what? The 11 plus the 50% again multiplied by what? The 7. I get my 9%. Or somebody can also say the 50% bracket open, the 11 plus the 7%, and he or she would also get the 9%. So this is how we determine portfolio expected return if you have been given the individual expected return of the investments, or you have not been given the individual expected return of the investment. If you have any question, raise up your hand. I'll give you a call, put you on floor, and then I'll explain for you. So this is basically how we determine the portfolio expected return. So those who want to copy or jot some notes, you can copy. Let me minimize this more so that you can have access to all the screen. So this is what we just looked at right now. We copy it and then we move on to the next aspect in the next 30 seconds. Okay, let's move on. Now, we also learned how to find the variance. We also learned how to find the variance. And you should also bear in mind that what we are doing now is portfolio. So I told you from the initial stage that there's a difference between standalone investment and then portfolio investment. What we are doing here is portfolio, but you need the information from the standalone investment before you can build your portfolio. Now, we learned that to find the variance, so let me go back small so that you appreciate what I'm about to explain for you. We said to find the variance here, I gave you the formula here. To find the variance is equal to the probability of the investment multiplied by the expected return of the investment you are looking at minus the required return of the investment you are looking at, all squared. So the probability of the investment multiplied by the expected return of the investment minus the required return of the investment. And if you could remember this particular illustration that we did, the Sky Resort and the amusement park investment, the one we had the 7 and then the 9%. We solved for the variance that very day, and we had the variance to be 0.021 for the amusement park and then 0.0124 for the Sky Resorts. And we said that, we went ahead and said that if you squared the variance, you get standard deviation. So somebody can say that standard deviation is equal to a squared deviation of the variance. So when you squared the variance, you get what? Standard deviation. So we squared this particular variance we had over here, and then we got a standard deviation of 14.18. And that very day, I told you this particular illustration will be used to solve a lot of questions in this handout. The reason why it is like that is for you to appreciate the differences and the similarities among whatever we are saying, so that you see that one investment, depending on where you find yourself and depending on whichever variables you have been given and whichever variables you are looking at and whichever result you want, you know how to manipulate your variables to get your answer or get whatever you want. So that is just the variance formula I gave you that particular day. So in our illustration over here, if we say we want to find the portfolio variance, which one is our probability? We found out that the probabilities of the investments now are 1/3. So the investment probabilities we just found right now is 1/3. Now, the portfolio expected return we had was how much? was 9%. So bear it in mind. The portfolio expected we have now is 9%. So if you are saying that variance is equal to the probability, bracket open, the expected portfolio return minus the individual required return. Then what do we mean? If we want to find the variance for this particular one, then we will say that variance should be equal to the probability of the first investment section. The first investment section is what? Recession. So let me use probability of R, bracket open, the expected portfolio return minus the required return of recession, brackets close, plus the probability of the second section. We have recession, we have normal. So probability of normal. So take note, I'm representing them by variables. Bracket open, the expected portfolio return minus the required return of normal plus probability of boom, bracket open, the expected portfolio return minus the required return of boom. So this is how I'll write my formula to solve this particular illustration. So if I got to know that my probabilities for this investment is 1/3, then the probability for one here is 1/3. The portfolio expected return we found was what? 9 minus the sectional return of recession. Recession we had 5.5. So sorry, I should have squared this one. Raise the power 2. Everything here squared. So everything here must be squared. Good. So I know my probabilities to be 1/3. Portfolio expected return I had was 9%. So you can see that this particular 9% will run through everything that we are doing here. This particular 9% is running through everything over here, and same as the formula over here. So it is running through over here. So you should know that this, your portfolio expected return, is very, very vital in whatever you are doing. So this is portfolio expected return. When it was standalone, we said the investment expected return minus the required return. This is portfolio. Are you getting the scenario? Good. Minus the first 5%, this particular 5% is what I'm talking about over here. Then the second one, 1/3, the expected portfolio return minus the 9.5. This particular 9.5 is this 9.5 you had over here. 1/3, 9 minus the 12.5. And this is the particular 12.5 you had over here. So therefore, when you finish everything, you'll be getting 0.0010. So when you go to your question and you are seeing the information, the variance, so this particular variance over here, there is a way we can also use this one here and this one here to get that particular variance, and then I'll show you that one too as well. So assuming we have not been given the individual investment variances, this is how we will get the variance. If you have any question, raise up your hand. I'll give you a call. Or if you don't understand, raise up your hand. I'll call you and then I'll explain for you to understand very well. Okay. Now, from the variance, we will be looking at how to calculate the standard deviation. The standard deviation. How to calculate the standard deviation. We said that when you squared your variance, you get standard deviation. So somebody who found his variance will just square the variance and get the standard deviation straight away, like this. You just square your variance, you get a standard deviation. Are you getting the scenario? Or you square root the variance here like this straight away. So everything that you had here, you just put it in your square root over here, and then you get the answer straight away over here. And I must reiterate that anytime you are solving it, kindly solve the question systematically in steps. I think I did that for you at the beginning of the lecture. Let me see if we had it. I told you that this your lecturer, he wants everything to be solved systematically. So when you are solving the question, please and please and please again, kindly solve it systematically. Break it in steps. I think we did it before we started recording the work, so it is not here for me, but I assume you know what I mean. So let me just make an example here for you so that you see what I'm saying. So for example, when I come here like this, if I'm solving for this question, it means that I will solve for 6 multiplied by 4 raised to the power 2. I'll get an answer. I place it here. 4 multiplied by 5 raised to the power 2. I get an answer. I place it here. 2 multiplied by 6 multiplied by 4 multiplied by 18, negative 18, negative 0.18768. So all this one will also be multiplied and I'll get another answer. So it means that in my next step, I'm going to have square root of, let's say this answer is 20. So square root of 20 plus 30 plus 25. That's going to be my next step. Then the third step is going to be square root of adding that 20, 30, and 35 in the third step. Then the fourth step, I will get my final answer. That is how I mean we should solve it in steps. But don't worry, when we started solving the past questions, you will see how it is being done, okay? So that by then I'm preparing you for examination. So you definitely know how to answer your questions for examination. So this is how you get your portfolio standard deviation. Any question? If you have any question, raise up your hand. I'll call you and then I'll explain for you. If you don't have any question, I have a trial test for you. So you copy it. So I have a trial test for you. Assuming you have two securities A and B in a portfolio with their expected returns and probabilities as follows. So expected return of A is 17.4. Expected return of B is 2.7. And then with A having 0.4 probability, what is the portfolio expected return? So this is the question I have for you guys. And you are to use the time now is 10:57. You are to use the next 10 minutes or 15 minutes to solve this question. You discuss among yourself, and we'll come back exactly 11:15 to continue. I said we are coming back what time? 11:15 to continue the second run of today's lesson in business finance. So in the second round, we are going to be looking at covariance and correlation. So before then, you guys will discuss among yourself and get an answer for this question. Please don't wait for me to come and call you and then you tell me you are now doing it. I don't like that. Make sure you solve it. If you have any problems, you let me know and then I'll help you do that. So you are coming back 11:15. That doesn't mean that you are stopping.
The fridge. Now the current is every evening there is down.